All right. So the this today we're going to be learning about Git, and the method which I'm going to teach you Git is a little bit different from what you see on the internet. Mostly, um, because I like to. I think I understood Git more when I understood how it works. For a lot of people, Git is like a black box. It's just like people just execute commands and hoping for things to happen. Or they just simply learn by heart what to do and they don't have a feeling for what's happening. So it's important that we get this out of the way. That's one thing. The other thing is the question comes out and we ask like, what is Git, right? Now Git is not GitHub. Just to be clear here, GitHub is a website, or sorry, well, let's say it's a host. It's a place where you can host or push your code and save it there in the cloud, like on the servers. Okay. Git, on the other hand, is the actual source control management, which manages the source code of your program or of your product which you are making. So, and it's actually something which is called a distributed version control system. And you see here it's called Git-SCM. Okay, SCM means source control management. Okay, and Git is actually made by Linus Torvalds. And Git in English, I think it's meaning like a hard-headed person or think they are always correct. Like it's negative, it's arrogant, not something, not a positive word rather. But Linus, according to him, quoting himself, he said like because he's egoistic person, and he is actually when you watch his talks, he actually like names the projects after himself, including or after his characteristic, including Git. So he made first Linux and then he called Git. So that's according to him. Now, what's happening? How Git came to be was Linus was working on the Linux kernel, and then he had people working with him, like contributing to the source code. And in order for them to exchange code, the first thing they did was actually they used something which is called a tarball. And a tarball is like it's literally written like tarball, right? So this is or something like I think it's written like all together. Now a tarball is an archive. You can think of it like it's not a zip, but you can think of it like zip. It's an archive of all files like just joined together. And what he did was he was actually like if he would like to contribute, if he would like to, for example, adjust the source code or something, what he did was he will like take the code of the Linux kernel, archive it into this .tar file, and it's like literally like .tar file. Okay, it was like that. And he was like sending it to the people whom he was collaborating with. And obviously he got sick of it. But then he looked at, I think it was called Bitkeeper, I think it was called back then. And it was a distributed source version control as well. So like Git, similar to Git. However, Linus was modifying the source code of Bitkeeper all the time, and he's just adjusting it to himself, like as he wants, and so on and so forth, like adding the stuff which he needs. Apparently, he was trying to commit it back or something like that. The main thing is that Bitkeeper got super annoyed and asked him to stop doing this altogether. So the guy just got angry, and then he just simply sit down, and he said actually in one of his talks, he sat like down for 15 days and he just simply got Git made. He just made Git in 15 days. And he was like using it to keep track of all the Linux kernel source control, like source code all the time. And he was collaborating with people in that way. And somewhere in 2005, I think, or maybe a little bit later, actually, no, actually even later, I think, maybe. He actually let people use Git So people were having Git, and then they made their own servers, and they just simply host the source code somewhere, and they were just simply like exchanging. They were exchanging their source code, like committing it to a server, and then they pulling back. Now, the interesting part about Git here is that every computer, which, for example, gets involved in a project, has a complete copy and complete history of the actual source code. So, for example, you worked on this code, for example, you worked on a project for about a year, and you were keeping like submitting, like you update your code and you save it and then you commit it or you upload it to the server. And then you do that for every day for a year. I come along and then I join you in the project to help you out, for example. When I actually pull the source code, I will have every single code change you made, which you have submitted to the server, because maybe you changed the code, but you never submitted it, right? So every change you made that you submitted to the server, I will actually have a copy of it, right? So I can actually go back 1 year ago, for example, and see how the project, for example, started, for example, right? So you can do that. So this is the cool thing about Git. It's actually distributed. So the interesting part here is if you actually like, for example, you wanted to work on something and you are traveling somewhere. So for example, you are working with a team, you have a copy of the repository with all of its branches, with everything every single team has made, like every single person in the team has made. And you, for example, travel on an airplane, right? And you wanted to continue working. Now you could have, because you have a copy of the whole history of everybody who actually worked on the project, you can actually say, okay, person X have actually finished a certain part of the code. Let me check out what he has done. And you just simply check it out. You don't need internet. And you check it out. You change the things and everything, and you commit it. When you commit it, you apply it. You apply it to your local repository. You have a repository on your machine. You keep it there. Then, once you are done, once you get out of the airplane, once you have, for example, internet, or you have internet on the plane, it depends on what kind of ticket you have. For example, when you get back off the plane, for example, where you were offline, when you get back to the world and then you get connected, you can actually push all your changes to the server, everything which you have done. And when somebody else comes in and he says, okay, give me the latest changes, they will get exactly the latest changes you had in your code. You made for the code, I mean. Now, the question here is how to use that thing, right? It is very important to understand that one of the things that's going to happen to you when you graduate and then you start working at a company, the first thing they will do, they will give you, here's your workstation or your laptop, for example, or your machine, which you're going to be working on. Here are your credentials. Here are your tasks. The link to the GitHub repository where you're going to pull the source code is this. Pull the source code and start working. Once you finish your task, commit it for a pull request. This is exactly what's going to happen, right? I mean, obviously you're going to be onboarded on the project. People explain to you what's happening and so on and so forth. I mean, I'm skipping all the fluff, but I'm giving you like the real life, what's going to happen when you just simply like get your job. It's going to be exactly that. So we think it's a good idea that we prepare you a little bit and then tell you, okay, here's something that you really going to need. And it doesn't matter what kind of a developer you're going to be. Are you a full stack? Are you a front end only? Are you a back end only? Are you a game developer? Are you whatever developer you are? You most probably going to use Git. Game developers, we usually use something else other than Git because Git is not efficient for huge files, and we're going to talk about that later. But for everything else is perfect. So in order for you to work with this, I advise you that you go ahead and create yourself a GitHub account. Not right now, not for this moment, but create for yourself a GitHub account with a good naming, because this is going to be more like a quote unquote your CV, I would say. And you download Git from Windows or Linux or Mac, whatever operating system you are on, install it until the end, like just Go with the default choices. You will not have a problem. And that's it. Git also has a book which you can read online for free. It's called Pro Git, which explains everything you need to know about Git, how to do certain commands, how to do certain things. So if you get lost, you can actually see the documentation, see that book. I think you can even buy it from Amazon. You can download it as PDF. I mean, it's there for you to grab. Okay. Now, it is actually very important to understand that you have to understand how Git works, and this is one of the things which is the objective of this class. This is, for example, some person, I think, I don't know, Jenik Arndt, I don't know how do you pronounce his name. This, she or him actually made an interesting map telling how actually Git works in terms of the commands you execute and the effects that takes place. But I'm actually gonna here you go. I'm just gonna paste that into the chat. So you're gonna have this. So this is for learning. This is the software which you need to install. This is the, hang on. This is the actual book, official book. Okay. And one more thing, I'm using something which is called AllMyPush, which is a shell extension. I'm using Windows Terminal. So if I start terminal, or rather, actually, I will start it from here. Okay. This is how my terminal looks like. And I'm using the PowerShell, Microsoft Visual Studio shell, PowerShell, because I could actually, I cannot remember right now anymore the name of the command, but I could run, I could write actual code in C# in shell if I wanted to, so it was fun. There is actually a video tutorial how to make this, how to make the shell of yours similar to mine. It's gonna be, I think, hang on, let me check. It's a relatively long there we go. It's a relatively longer tutorial, but the guy is actually taking it very, very slow, step by step. Here it is, how to make your terminal similar to mine, or similar to his rather. But you don't need WSL or anything or any of that stuff. But anyway, I'm just sharing it with you so you have that resource. Actually, it's very cool to have it because you're gonna see later on with Git, you can see even like interesting like things like it gives you interesting icons telling you what's exactly happening in your repository. And for the time being, for the introduction, we will not be worrying too much about like committing to remote and stuff like that. We're going to talk about that in the next lesson. However, we're going to mostly look at Git visualization here, which is also, this one is a good training, even though not all commands run, but this is a good visualization thing you can use in order to see how things work. All right, so now that's the prerequisites are out of the way. Now you know how things work or look like. Now I can actually go ahead and work with Git. Now, if you would like to initialize to create a repository, all what you need to do is just simply say git init, right? So right now you initialize a repository, and the repository is within the folder which you are in. So I'm calling my folder learning Git, and I'm saying git init. And it says initialize empty repository in this and this user, blah, 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 and like in that directory which I'm having in. And if I look here, I'm actually showing all hidden folders. So the folder name is actually prefixed with a dot. So it's called .git, okay? And it's hidden. So if you don't have show hidden folders, you will not see this. Now, if I get inside here, I get a bunch of files. Now, this is super important. Do not delete that thing, okay? This folder gets large, by the way, depending on how big is the project, or how much of a history people kept, because sometimes when the project like gets for so long, some people sometimes truncate it, like they remove part of the very old history which nobody cares about to make this to make the repository a little bit smaller and manageable. Otherwise, you're gonna get terabytes and terabytes, which everybody like. Imagine you joining a project after it's been working on for 10 years, and then you have to download 2 terabytes of data for any crazy reason, just for you to start working on the project because nobody was truncating things. I mean, obviously I'm exaggerating, but you get the idea. Okay. Let me see. I just would like to prepare this. I think I have a command somewhere where I can actually visualize what I'm about to pull off in a minute, because you need to see it in that way. Give me a second. I just need to find it. The idea here is I'm trying to refresh the folder in the terminal, and I think it's going to be useful for you to see how this looks like. Okay, so if I actually go ahead here and say there's a command called tree, right? And the tree is showing the subfolders of I mean, how your folders look like. I mean, ls will, I think ls-a, or was it all? Oh, sorry. Okay. Anyway, tree.git. Now, tree is actually like is listing out the directory of like the directory tree, like how is the hierarchy of my folders are. And I think if I hit put /f, it should show me all the files within. Okay, so it show me the directory and show me the files as well. And I'm going to use that in order for me to write a very simple script here. So I can just maybe split the tab and we'll try to maximize this as much as I can. Okay, so clear here, so we are reset. Okay, so I'm gonna have here while true, because I would like to have this infinite loop. First of all, clear the screen, the command which I was writing, by the way. So clear the screen, then do a tree/f on .git, okay? And then start sleep, because I would like to refresh the screen every 1 minute, or every 1 second, sorry. So I'm gonna have seconds 1, okay? So this is all what I'm doing. It's just, it's a while loop, it's an infinite for loop, or sorry, infinite while loop. It clears the screen, lists the directory, then it sleeps for 1 second and just does the same thing again. It's like thread.sleep. It's nothing fancy here. And if I hit enter, nothing happens, which is great. What's happening here? Line 1, character 7. What am I missing? What am I missing? So wild, character 7. So 1, 2, 3, 4, 5, 6, 7. Actually, true needs that. Sorry about that. So if I hit enter, right now it refreshes every second. Okay, this is my folder. All right. So what I could do is right now tell you what's happening in Git before I carry on, because you will understand exactly what's happening here once you get these things gets refreshed. So MS Paint, and let's see. So your source code passes through 3 phases. Okay. First thing, you have something which is called your working area. Oh, your working area. Second, you have something which is called staging. Next is your repository. Repo. I was just going to call it repo. It's too much to write with the mouse, to be honest. So you have the repository. So you have the working area, the staging, and repository. And what's happening here is what you usually do, you create a file, you work on it. This is what you are working on. The moment you say git add, there's a command called add. It will actually move the file from the working area to the staging area. That means right now it has actually been it's like been prepared to be pushed or committed to the actual repository. Okay. So once you do that, you can, for example, start working and changing the things as well, still changing whatever you are actually changing, right? And still keeping the things staged. Once you are done with staging and you would like to commit it to history, right now it will hit the Git tracking, the hard drive. Well, actually it's hitting the hard drive anyway, but once you would like Git to track it, you will actually say git commit, and then you will commit it to your repository. Okay. Now you can actually undo this, obviously. You have an undo for that, but of course it has a command for it. You can actually, I would say you can undo this as well to some extent. Now this is all local so far. This is your local machine. Okay. Now here's the interesting part. What you can do is once it reaches here, you can say push, and it's literally called git push. And once you push it out, it goes to the online repo where your server is holding the thing. Okay, where your server is holding the centralized bit of your source code. Okay, so so this is like the stuff which is being pushed, like how things are going. Now the question boils down here is we said that it's actually following the source code. Now what is it exactly following? Right, that's the question. So what does Git keeps track of? Git keeps track of 4 things. Something which is called the tree, which is your path. Something which is called a blob, which is a short for binary large object, which is in fact your which is in fact your source code or an image or whatever. And then it keeps track of something which is called your commits, which means you're the transaction, I would call it, for example, like this, the action which you take in order to push things into here. Okay. And it keeps tracks of something which is called tag or tags. It doesn't matter, like so it's a plural thing, tags, because the interesting part here is, which you're going to see in production, what people do, when they, for example, commit a product to customers, they actually say, okay, this has been committed. This is, for example, version 1.72 of the project. right? 1.72 can be actually attached as a tag to the actual final commit before publishing the product. And this is actually very important to have because you need to, as a programmer, sometimes you get a problem, and you have seen it a lot in I think you have heard about them or seen it a lot with the software which you use every day. Sometimes they say, okay, we reverted back, or please revert back to, but it's actually quite rare right now. But people revert back sometimes to older versions of a software. And even we as developers in the middle of production, sometimes we would like to see what happened or has changed between two releases. So we get back to the release with a certain tag and we look at it, right? We need to know which commit. That's why it's like tagging is like highlighting. It's like putting a bookmark somewhere that says this is the version of a software which we published. Now, obviously, you can use tags for many other things other than just simply labeling the release version, but these are the things which Git actually keeps track of. Okay. All right, so let's actually go ahead and create a file just for Git to track. I'm actually giving you a lot of background here because it's actually important to understand what's going on. Otherwise, everything is gonna be just a bunch of commands and nobody have a feeling for it. So I'm gonna create a new, fine. And here I'm gonna call this a my program.cs. And I'm actually just having a file. I don't care really about the, let's see, opening with Visual Studio Code. I really don't care about the project right now, Visual Studio Project. I would like to have the most minimal thing, so we can like remove all the fluff and other generated project files. And right here I can have a using, okay, not that fast. Using system, namespace, my program, and then here you have a public, or actually, yeah, static void main, and I think it was, whoops, I think it was string args, hang on, like so. And yeah, and right here you're gonna have your infamous console write line. Hello world, or rather, hello Git. Okay. So let's say that you have a program like this, hypothetically speaking. Now I have actually saved the file, and as you can see here, nothing happened. Like nothing is being changed here, isn't it? And here's the interesting part too. You are in fact here. Okay, you are in this place. Now, if I actually say git add, I could name the file which I would like to add. So I can say my program.cs. Another way of doing this is I can say git add dot, and git add dot means that I can add everything, all the changed files. Now it's up to you what you would like to commit. Some people commit certain files. Some people add or stage, sorry, they not commit, they stage all the files. So I would like to move right now this file from being in working area to the staging area, right? So I say git add. And the moment I did that, you see here, this thing appeared, right? It wasn't there before. We're going to talk about that in a minute. And of course, because I'm having this plugin for the Windows terminal, it says here I'm on the master branch. Actually, right now, Git is naming it main, but I have an older version of Git. That's why it's not updated. Now I'm in the master branch, and here I have, it says that I've added one file, okay, and it has been checked in, like it has been in the staging area, okay. Now I will actually finish this by saying git commit -m. It means like I will add a comment on the commit. So I'm just commenting what I have done, because otherwise, if you commit without commenting, people will not understand like why you have why you have submitted this file to the server, for example. You have to describe yourself. But for the time being, because we just started the project, I'm going to have the infamous comment which says initial commit. That means this is the first time we are making this project. So I'm going to hit enter. And then once I hit enter, watch here, it will actually like start to expand a bit. And immediately you get this. Okay. Now let's analyze this. Let's see what's going on in here. So the moment I hit commit, things happen in the .git folder. So what all that mean? I'm gonna go ahead here and go inside cd, change my directory to git, and right now I'm in here. So I'm in this folder. Now all I'm gonna do is try to investigate what the heck are these stuff, right? And if you actually navigate this by hand, so if you go here and you go into, I don't know, objects, 58, and this, and if you try to open this in Notepad, for example, let's say, let me grab this here, and you put it here, you will end up with this, just binaries, right? So let's see what the contents are. So I'm going to go here and say git show, and then I will write in the SHA. This, what you see here, is a SHA-1 hashing algorithm. It is some time ago it was used for security. Right now it's not it's not being used for security at all. It's used only for tracking. I think the collision is nearly like, I don't know how many billion or multi-billion breakers you have to create in order to have a collision in the hashing. We're going to talk about hashing and collision and algorithms and data structures. But again, SHA-1 is the actual algorithm. It's written like this, SHA-1, okay? You have, I think, SHA-5 probably, I can't remember anymore. Anyway, so I'm gonna write in the initial like couple of letters just to identify it. So 58, and then I will carry on here, ACA, and I think it's enough for the time being. So if I hit enter, this, for example, this object is telling me what I have committed. So this is, do you remember when I said it actually keeps track of a commit? This file happens to be the commit which you have committed. And if you look at this, that means actually that Git is following or tracking the contents of a file, okay? Which is super important. Git follows or Git tracks the content. Some source version controls, they do not follow or do not track the content, by the way. They just simply track, has the file changed? If it has changed, it will tell you, hey, this file has changed. It doesn't tell you where or what. And this is why, for example, Git is very bad at handling big files. So for example, if you have a 1 gigabyte, actually, I think Git can handle a file up to 100 megabytes. The moment it exceeds 100 megabytes, you have to use something which is called Git LFS. And this is something you will not see unless you are working with large files. And I don't know if you're going to see that as a full stack developer, to be honest. As game developers, we see it a lot, but we need it. If you are using Git. Actually, for game developers, it's much better to use something which is called I think there are many. You have SVN, which is something super old, but a lot of people use right now Perforce for game development. But that's another story. But I'm just informing you what's happening here. So keeping track of internals of the file, like content of a file, you have to make sure that just your files do not exceed that humongous size. Otherwise, it's going to be very slow for Git to handle. All right, let's actually check out what are the rest. What are the other things here? So I'm going to have git show 9f or 9f7 1a, and I think it's enough. I mean, I could carry on. You could copy this, but I just need only the first like 3 letters to make sure it's identifiable. And right now this is a tree object. You see, as I already have mentioned, Git keeps track of a tree, right? And that tree means like the file names or the file locations. Where are they? And so on. Okay, let's actually carry on. Git show A7 F0, for example. And this shows the content of what I have committed. So this is the commit. It says the email, the hour when I have actually committed that thing, the program, everything is actually just simply mentioned in there. The only thing which has not been, which has been actually like mentioned here is like, so this is like the commit itself, but here is only mentioned the contents of the file. Okay. So so basically you can think of this as your blob. Tags, we don't have tags yet because we didn't tag our commit, but I think it's called git tags, git tag, I think git hyphen tag. Or I think something like that. I can't remember anymore the command. Hang on. I think, for example, we can say version 1.0, and I hope that I didn't make a mistake there. Git tag or git tags or something like that. I really cannot remember anymore. Let's see. Git tag. Oh, there we go. So there you go. So here you go. It says tags and then version 1.0. And this is like me tagged this commit. Okay. Here's another interesting tool for you, git k. And git k is an actual visualizer of your git. Here you go. Here's my tag. Here's the branch where I'm on. And it says this is my initial commit. And I don't know if I can I? Oh, perfect. Okay. And here you go. It says this is my commit. This is my information, who committed this thing with a comment. So initial commit. Okay. And that's pretty much it. So this is for git k. So if you write command git k, it will visualize the thing. Now, most people actually are using something which is called Gitkraken. This is actually paid. I think it has a free version for it. You have Git. You have the GitHub desktop application, a GitHub client, which you can use in order to do, also the same thing. But instead of writing in a command line, you can just simply click buttons and it will do the job for you. I think that's these are the two ones I can remember right now off the top of my head. But a lot of people are using the command line, and I've seen them like only prefer the command line. So yeah. Okay. Any questions so far, by the way? Chat.
I have one.
Yes.
I don't know if I get it right. We have working, staging, then repository, and when we do commit or push, is that the same? We go from local to online server.
No. When you say commit, it goes to the repository. Right now, it is in the repository. This is your repository right now, right?
Oh, okay.
When you say push, it goes out to the server.
Oh, all right.
Mm-hmm. Yeah. So hang on. So this is add. This is commit. And this is push. Okay. What I have done so far, what I have done here, like creating that file, have done something like this. So I said, imagine that I have a file. Oh, hang on. Let me try to and try to like refresh this thing. So if I had say, so you have the master branch, and yeah, it has the first commit, doesn't matter. So what I've done is I just simply said git commit, and it immediately just created a commit object. Now, obviously, the visualizer have made me one commit, the initial commit or the first commit with the SHA, as you can see here. Okay. So exactly the effect of what we have done just right now. Okay. I would actually advise to take a break before we carry on with this. Okay. A break of 10 minutes and we get back. So it's right now 5 and 10. We get back and continue. All right. Can you hear me?
Yes.
Can you hear me now?
Yeah, we hear you.
Oh, okay. Because all right, because my headphones is keeping like muting the mic for some reason. All right, so okay, carrying on with work. So last time we stopped at git commit. So right now we know how a git commit looks like, and a git tag and everything. Right now, let's actually visualize certain things. So what you usually do in Git is not only just doing like, you know, making just simple like commits and you keep like, you are not working alone all the time, right? So sorry, it should be like a Git commit. So most of the time people do not just work on their own and having this like that. Actually, like even if you are working alone, mostly you work with branches even. So at a certain point in time, you would like just to branch off to make sure that, for example, you don't want to pollute this. So for example, you say, okay, this is part of the source code, which I really like, and I would like to keep for now. But I would like just to simply like deviate a bit without, polluting that. And when you deviate, there are two choices. Either you copy paste the project into another folder and you test stuff, and then if you have bazillion tests, you're gonna have bazillion project copies. Or you can just simply branch off of that thing. And once you make a branch, is it like the whole history just goes in a different direction, like a tree, just you go in a different direction. So you can say, if you would like to create a branch and check it out right away, you can say git checkout -b. And checkout -b, what it will do, it will create a branch and move the head to that branch. Now, if you have noticed, there is some interesting head is going on here, and you can think of the head as your, let's say, as your hard drive head, literally, like. But okay, not the SSD ones, but the good old hard drives, like with disks and everything, and you have a head pin on that, right? You know how old hard drives look like? HDD. Come on. Okay. So this is your head, right? It's written there, read, write, head, right? So that's imagine it like this is the thing where you can actually move it to point somewhere, right? So that's what the head is about. Like you can move that head around actually. So let's do that. Let's actually check out -b and then the name of the branch, which is going to be my new feature. And right now, as you can see here, the branch and the master branch, both of them are the same right now. Like both of them are on the same spot. Okay. And the head as well. So all of them are having identical history so far. So what I could do, I could just simply say git commit, because right now the head is in fact pointing to the new feature, not to the master, just to be clear here. If I would like to check out master, I just simply say, if I would like to move the head to the master, say check out master. And right now it's on the master, but okay, fine, it didn't move the head. I mean, the visualizer didn't move it, but let me get back to my new feature, okay? Oh, actually it says here, head pointing to my new feature, you see? And right now what I can do is just simply say git commit And right now, my new feature is keeping going ahead of master, right? Now, obviously, I'm not leaving here comments. I'm not saying git -m and then a comment. I'm just simply committing there just to get things going, right? Now, obviously, this guy is ahead of master, right? So you have branched off of master, and then you were working on this new feature, and you suddenly like it very much, and then you say, okay, that feature is good enough that I can get it back to my master branch where I'm gonna publish this from. I'm gonna publish my code or publish my build to the users to use. So what you usually say is you actually have to say, you have to stand on the branch where you would like to merge into. So for example, I would like to take my new feature, merge it into master, right? So I merge my changes onto master. I have to stand on master. And then I say git merge new feature. Hopefully I didn't inverse the thing. Let's see, if I inverse it, then I will just revert it. Yeah, there you go. And now I've actually merged it. Now if I say git commit, I'm gonna go with the master right now, right? The new feature is done, it's actually getting older, and that's it. And the moment I would like to update master, all what I need to do is just simply git checkout. I would like to branch off of it, sorry. My second new feature, and I should keep my namings a little bit, checkout -b, sorry. Now head is pointing to the new feature. I can simply say, and I can git commit, and things go forward. Oh. Okay. Now here's the interesting part. What happens in reality is, in fact, like, people usually do not touch master that much. I mean, master branch is like what we call where you commit the final code. Just to be clear here, we usually work on something which is called dev or develop channel or development branch. One of these three names you're going to see. A lot of people name it develop. And then once you make everything done, once the 10 people working on that project merge all their work correctly in develop, if everything is fine, they take that develop branch and they just simply merge it into master. And then once it goes inside master, the DevOps guy will grab the code or have actually prepared the server that once the master branch has actually been changed, it will immediately release the new application for everybody to use. Now, what's happening in reality is the following. You are not working alone. So check out master. So right now my head is at master, right? And then I can say git checkout -b some other feature, right? And I say git commit. And right now you have two people working on the same project, right? Imagine that for a second. Now, or imagine that you, on your own machine, you are doing both of them at the same time. One guy just tells you, hey, please finish me that feature. And then another manager tells you, please let's pause that feature for a second. Let's develop the other feature. And then you made both of the features and you would like to merge them back, right? So what you usually do here is that obviously you cannot go with master. So for example, let's say check out master. Again, git checkout master. I guess say git checkout and the name of the branch. Obviously, I mean, you can see that. And then imagine that somebody have committed some code into master. So git commit, right? And master suddenly came ahead. Now, obviously, there are a lot of merging strategies are in here. And a lot of people even sometimes against merging. Some people actually like to rebase, where rebase will give you a history looking like this, a linear history. There are a lot of people who are fans of linear history, and some people are actually against it for many other reasons. I'm not in any of buddy teams. I would like to have a good history that I can navigate And either I will follow the previous team's strategy or I will create my own strategy depending on the needs. It doesn't matter really that much. I'm choosing my strategy based on the project I'm working on and the needs of it. But usually rebase is kind of like the nicest way of looking at a history, and you will hear that a lot from seniors and tech leads. There's also an interesting part in GitHub Desktop. It actually gives you a choice. Would you like to merge and rebase, or would you like just to merge, like to have these kind of merging histories? You're going to get that question asked by the program. So just for you to know, if you see it, do not get surprised. But we are not going to discuss the rebase today. We are just simply discussing Git, how to work with Git, nothing more. All right. So actually, we don't even discuss. We will not discuss even merging conflicts or anything like that. We're going to discuss that in the next class, because I need you first to train working on this. I was just double checking a couple of things here before I carry on. Okay. All right. So, yeah, so what I wanted to say here is you can actually start merging. So for example, some other feature was actually good enough that can be going to my second new feature, right? So you can say, okay, I would like to merge, depending on how you agree with the team. You say, okay, where is the head? Okay, so git checkout my second new feature. Right now, head is there in that on that branch, and then you can say git merge some other feature, and right now it will create a history point that actually like that is actually merging the two features together. And then right now I can actually check out master, and I can say git merge my second new feature. Okay. Now here's one thing which probably you should ask. Do you see why the heck actually like this weird like commits are always pointing backwards? Right, this is one of the things which are also interesting. Also, the data structure for this, by the way, is called the enode or inode. It's actually written like this. It is similar to Linux file system. This Git in fact is using a data structure called I think it's enode, and it's a cyclic graph, a cyclic directed graph. Directed later to graph. I need to correct the spell, so it's a C. A cyclic directed graph. This is the name of the data structure. So there are no cycles. You cannot have cycles in this thing. You cannot end up in a loop on your own. So if you follow the arrows, you cannot go back here. So there's no arrow going back and then you end up in a loop. It's always going in a certain direction somewhere, but you will never end up in a loop. So that's why whenever you actually create a commit, it has to, like, you have to say, okay, where I came from, right? If you are building up a tree or a graph of a history, if you are initialized here, if you just initially committed something here, it just appears as a, like, here's the first node. When you make another commit, you will commit the second node. And if you notice, it doesn't point forward because it doesn't have anything to point forward to. Like look here. It doesn't point here because there's nothing in there. So, and you need to go back if you needed to. So going forward is fine. You don't need to know what's going to be ahead. You don't need to point to null, for example. What you really need, the information which you really need, is actually back. So you need to be able to go backwards, and that's why all of them are pointing back, right? I mean, besides being a cyclic and besides being the data structure, how it's being structured, but this is the purpose of it. You don't need actually to go forward. You only need to go back. If you would like to go forward, it's going to be actually easy. You just simply move the head to a certain point, and that's it. Okay? You can actually force the head to go backwards or forward. You can actually check out a certain commit like this. So you can say, as far as I remember, so git checkout, and then you get the hash of the commit or the SHA. There you go. For example, I would like to check out this guy. So if I hit enter, right now it says detached head, because I just simply moved the head to a certain commit because I would like to know what happened exactly here, right? And then later on, you can actually, once you are done looking at whatever you want to look at, you can just simply say, aha, okay, I would like to get back to my branch. So I'm going to say git checkout whatever, master, for example. And right now it's pointing to a branch, pointing to master. Okay. Now here's the interesting part. Let's look at this. So if we get back to our repository, what I could do, I can say git checkout -b, and then the name of my branch, which is going to be my new feature, because I'm out of names. So when I hit enter, right, I'm actually in the git folder, sorry. So I say git checkout -b my new feature. And I immediately created a branch, and you can see here, my new branch all of a sudden appears, right? So here are there's where like the heads are, right? Where the possible jumping points for the heads to go. Now, what is that thing, isn't it? That's the actual question. Let's actually create let's create some changes here. Let's have if I go here, I'm gonna go into my program, Sublime, for example, here, and I will edit that program. I will just simply say, instead of hello git, hello world, and I will close that. So right now I've changed my code here in that branch. So if I say git status will tell me exactly what's happening, right? What has changed, and that's it. This is telling me that right now nothing has been staged, so I'm still in the working area. So if I say git add my program.cs for a change, instead of just git add dot, just for fun. Right now it has been added, and of course something has changed probably here. I haven't noticed yet, but I'm just going to say git commit -m modifications to the program, or actually, how about this? Changed greeting output. Okay. Usually it's a sentence with at most 5 words or something like that. This is how you should name your commits, because you need to understand them once you see them. All right, so we actually have committed something, and something has changed right now. So if I say git show, oh, actually I need to go inside first. So cd, so I change the directory git. All right, so in here I'm just gonna say git show, and I'm gonna say C9958 for now. And there you go. This is actually my commit, practically speaking. And this is the SHA of the commit. Okay? So remember this. So it's going to be C99583D whatever, right? So C995. There's nothing else in C99. Now, if I actually clear this, now what the heck is these guys, isn't it? That's an interesting question. So I can say, let's see. So git show refs / heads / my new feature, right? Maybe I can cat that. There you go. So cat is, you can read files. Actually, like there are many subcommands for cat. Just check it out. I forgot the acronym for it, to be honest. Anyway, look at this. So the content of this file, my new feature, that it's an actual file. The contents is C99583D2B. So actually, when you think about it, a branch is just a pointer to a commit object, or yeah, it's a commit object, because we actually have looked at this, right? Haven't we? A couple seconds ago, we just simply like said, okay, git show, and then show me this whatever's under that hash, and it just showed you immediately the commit information. When I looked at the branch where I'm at, it says I'm just pointing to the commit. Okay. So that's actually interesting. Now let's actually merge things. So I'm gonna have git. Actually, I need to go backward first. Oh, sorry. Clear here. Git. No, actually, git checkout master, and then it will say git. We will say git merge my new feature. So right now, updating forward, right now I've actually merged the two branches. Okay, one file changed, one insertion, one deletion, because we deleted because I think it sees of the file like line replace as a deletion, I think. Git commit, I think. We say merged branches, merged my new feature into master. Oh yeah, okay. I'm just yeah, I'm actually done. Sorry. And right now, actually, you push the stuff to the server if you want to, because I already merged I already have merged my changes. Okay, so let me actually like stop refreshing this guy. So right now, you know how actually Git works, more or less. You could we could actually like create commits. So you create a file, you commit to it, you actually make changes, commit it to the repository. Then we actually create branches, so you can actually do some changes in one piece of code while the other changes never happened. So if you actually like go here and say -b another feature. Actually, you could use also my new feature, by the way. It will work with the same thing. We can say code my program.cs, and right here I could just simply say oh, as you can see here, Git actually Visual Studio Code already sees that I have a Git, so it says 1 second ago I actually have uncommitted changes, and it says modified with M, so it's actually kind of cool. Actually, what I wanted to show here, I actually made a modification for some reason. So I said we can branch, we could modify the source code, we could merge things. I just wanted to show you something. Honestly, I just somehow let's see. Yeah. What I wanted to show? That's a very good question right now. Let me look. I'm sorry, man. I'm sorry, guys. I just forgot. I wanted to show you something. It just went away for some reason. Happens for the best of us, I guess. Ah, right. Yes, yes, yes. I remember now. So I'm gonna actually have a git commit -m another feature. Now, if I don't merge anything, right, I can actually go git checkout master. And when I do that, look at the code. Okay, because it's on another branch, and that branch has just a different code, right? And if I actually just simply say git checkout another feature, because I already have, made changes there, it immediately appears here. I can actually show you right now. It like here, because I'm using Visual Studio Code and things are fun and everything. It's just tiny, so it actually does that. So let me just minimize this guy a bit. There you go. Git git checkout master, and if I get here, oh, for real now? Oh, oh, okay. There you go. Git checkout another feature. See, it just gets back here. So switching branches, it will change the content, even though I haven't merged anything. It just because changes happen on one branch, changes happen on another branch, and this is the cool thing about Git. It keeps track of things and keeps it clean. If you actually right now, if I give you right now this repository, if you pull it out from the internet, if I push it on the internet and you pull it out, you will actually see exactly what I'm seeing here. You can switch the branches. You can have exactly the same branches and everything. You can see exactly the same content. You can go back in time and you're going to see all the commands all the changes which I've made to the repository. So if I say git k on this guy, you're going to see exactly the same features and exactly the same stuff which I've done. Um, like I'm looking at here right now. So that's important to mention here. Okay. So I think I'm gonna stop here for now. Because in the next class we're gonna talk about undoing things and merge conflicts and stuff like that. Like what will happen if you have a collision between two people, like two people editing the same line of code, how to resolve this. Because this happens all the time in production, and people just get terrified when they see it, even though it's actually quite simple to handle. But you need to see these errors, so you will be like, okay, I'm okay looking at this. I can handle it. I will actually stop recording here.